So in the public section, we define the public interfaces, and this is where we declare or define public methods. And this is really important because this determines how people will be able to use your class and manipulate the object's private data members. So for example, with the string class, use the assign method or use the append method, and that let you manipulate the internal representation of the string which was stored in the private section. And there are various categories of methods. So first of all, there are constructors. And as the name implies, these constructors initialize objects. And there are a variety of ways that objects might need to be initialized. First of all, there are default constructors. And these, as the name implies, just sets an object to some default state. What I call explicit constructors construct an object to some explicit state. So let's say, for example, if we have a time class, what should be the default time? Maybe it's midnight, maybe it's noon, maybe it's 8 o'clock in the morning. But the explicit constructor would let someone set or construct a time object for a specific time of their choosing. Then we also have copy constructors. And these simply let us construct an object using one that already exists. Effectively, what we're doing is we're making a copy of it. And we'll get into this a little later. It turns out that C++ provides a copy constructor for us. However, we're responsible for implementing default and explicit constructors. Then we also have set methods. And these are also known as mutators or accessors. And what they do is they set values for specified private data members. So for example, if I wanted to change the hour of a time object, then I would use a set method to do that. There are also get methods. And what these do is these get values for specified private data members. And these are also known as observers or inspectors. And what these let us do is maybe we want to just, so first of all, we'll be talking about a time object, but the get methods will let us access the constituent parts, the individual private data members. So sometimes we'll want to talk about the time object itself. At other times, we'll want to just deal with the hour of the time object or the minute of the time object, and get methods let us do that. Then we're going to need a variety of output and input methods. We'll talk more about that in just a minute. There might be object-specific methods. So there's something specific about the string class, something specific about the time class. And, these will just be things that you implement based on what the class is. We can overload operators in C++. And what this is, we'll get into this a little later, but let's say that we want to add time. I want to add one time to another time object. And I can implement a method called add, but I can also overload the addition operator in C++. And then finally we have destructors. And we'll talk more about these later. Essentially what these do is these, clean up when an object is destroyed, deallocated, freed, or destructed. We don't have to worry about destructors right now as long as we're using the basic types or class objects with the destructor. There's a default destructor that we get when we implement a class, and it works just fine. We'll have to implement our own destructors when we get into dynamic allocation and things like that. So with input and output methods, so keep in mind that you have some application that you're writing, some software application, and a lot of the information that it uses will be stored on some sort of a hard drive. Maybe it's stored on a flash drive and flash memory. Maybe it's stored in the cloud. So this actually could be a network connection. And then there'll be some person using the application. This is our user. And you're going to need input and output methods for the application to communicate with the hard drive, and you're also going to need input and output methods to communicate with the user. And a lot of times the information that you store on the hard drive is not necessarily the same information that you're presenting to the user. And just as a very simple example, let's go back to this notion of time. Maybe on the hard drive you're storing time as 1423, two integers, right? This is an int hour, and this is the int minutes. And you're storing this in what we call military time. But to the user, you're actually presenting to him or her the time like this, because maybe that's just how the application works, or maybe the user in his or her preferences has said that they want time to appear in this format. Look what we're doing here. We're only storing two integers, but when we actually present it to the user, we have an integer which is different than 14. We actually add the colon in as part of the formatting, and of course minutes is represented as it's being stored. And then because it's in the afternoon, we add the PM acronym. So the way we store things on the disk may not be the way that they're actually presented to the user. And so what we need is a method called read, which reads the time, and I'm going to call this the internal representation. And this is the external representation of time. And our methods for communicating this information are going to be different. So read is going to read these two integers. And of course, when we write the information back to the disk, it's going to have to write these two integers. However, if we print the information to the user, then he or she has asked, or we're presenting it to them in this format. And of course, if they enter the information into an interface, then they'll enter it in this format, and then that's communicated to the application. Now, how the application actually stores it, does the application store it in this format or does it store it in this format? That's a design decision. I think for me, I would probably store the information in this internal representation. I would read and write it to the disk using this internal representation. And then when I needed to present it to the user, I would simply convert it using the print method. When the user entered this information through the enter method, that I would convert it and store it in the application using the internal representation. So input and output methods, we're going to need a read method and a write method for communicating with for the application to communicate to and from the hard drive, and then we're going to need an enter and a print method for the application to communicate with the user.